The appeal of strong, well-developed forearms is undeniable. They are highly visible, they signal physical capability, and for anyone training at home, they seem like a muscle group that should be easy to target without a rack of heavy weights. Scroll through any fitness feed and you will see promises of massive forearm growth using zero equipment, a couple of light dumbbells, or whatever household items you have lying around. But these viral home routines consistently ignore the biological reality of how muscle hypertrophy actually works. To force a muscle to grow efficiently, you need heavy, micro-loadable mechanical tension. In a commercial gym, you have barbells and highly adjustable cable stacks to apply that exact tension. At home, you usually don't. Because we lack access to precise, heavy weights in a home environment, trying to force forearm growth requires a steep compromise between the actual muscle stimulus you gain and the sheer amount of time you have to invest. To figure out if a home exercise is actually worth doing, we need to evaluate it based on its return on investment, rather than just chasing a localized burn in the muscle. This chart maps out that exact relationship. The vertical axis measures the actual impact on hypertrophy and strength, while the horizontal axis measures the time and fatigue cost required to get there. In an ideal gym scenario, you can load up a heavy cable wrist curl and get a massive stimulus in just a few sets. That sits perfectly in the top left. High impact, very low time cost. But at home, those ideal options vanish. The methods available to us scatter across less optimal zones, forcing us to accept specific compromises. Which brings us to the real question. Is spending 15 minutes explicitly isolating your forearms at home actually moving the needle, or is that time better spent adapting the primary exercises you already do? The most common workaround for a lack of heavy equipment is high-rep isolation. This involves using very light dumbbells, pulling thin resistance bands, or wringing out thick towels. To make this work, the input requires pushing sets to 20, 30, or even 40 repetitions. Because the weight is so light, you have to take the muscles strictly to the point of absolute failure, just to ensure all the muscle fibers are recruited. Biologically, the outcome here is reliable. Taking light weights to failure creates significant metabolic stress, delivering a massive pump and building dense local muscular endurance. The trade-off is the sheer friction of the process. Pumping out 30 reps of wrist curls for 4 sets is tedious. It eats up a massive chunk of your workout clock, and it is strictly less optimal for absolute maximum tissue growth compared to heavy mechanical tension. Looking at our chart, this plots exactly in the bottom right. You are paying a very high time cost for a relatively moderate to low hypertrophy return. The method works, but the massive time cost makes it an incredibly inefficient primary strategy for a standard daily home workout. The second common home approach is isometric integration, which usually takes the practical form of heavy farmer's carries. The input involves finding the heaviest, most awkward objects you own, like a loaded heavy backpack or 2 5-gallon water jugs, picking them up and carrying them until your grip gives out. The outcome is highly practical. Heavy carries build exceptional real-world grip strength while simultaneously forcing your core to stabilize a moving load. But the trade-off is twofold. First, your progression is hard-capped by the absolute maximum weight of the objects in your house. Second, carries only train isometric strength, meaning the muscle is holding a static position, not moving through a range of motion. To fully develop the bellies of the forearm muscles, you need dynamic flexion. You actually have to curl the wrist and close the hand against resistance. Static holding leaves a portion of potential growth on the table. We can plot household isometrics right here in the middle left. The time cost is very low, and the functional impact is solid. Heavy carries are highly efficient for practical strength, but because they lack dynamic flexion, they will not maximize pure forearm size. The third method attempts to cheat the system entirely: compound grip modifications. The classic example is draping a thick towel over a pull-up bar. The input is simple. You take a standard back exercise, like a pull-up or dumbbell row, and modify the handle to make it incredibly difficult to hold onto. The intended outcome is total efficiency. By forcing maximum grip engagement during a compound lift, you theoretically train your back and your forearms at the exact same time, cutting your workout duration down. The critical trade-off here comes down to basic anatomy. Your forearms are a small muscle group. Your back is a massive complex of large, powerful muscles. Under a heavy load, your small grip muscles will almost always fail first. This split bar chart illustrates the physiological bottleneck perfectly. Your grip hits 100% fatigue and fails, forcing you to drop from the bar, while your back muscles only reach 60% fatigue. Modifying compound lifts this way is a trap for most lifters. You save a few minutes of workout time, but you actively sabotage your primary back hypertrophy by ending the set long before the target muscles are actually stimulated. With the trade-offs mapped out, the right method for you depends entirely on where your specific fitness bottlenecks are. This decision tree flowchart asks one primary diagnostic question to determine your path. Is your grip failing during normal pulling exercises? If the answer is yes, you fall into the functional beginner category. Your grip is an active liability. Your priority is to protect your heavy back workouts. Do not combine grip and back training. Instead, perform your normal pulling exercises and invest exactly 5 minutes at the very end of your routine for heavy carries or dead hangs. If your grip isn't failing, we ask the second question. Are forearms a specific aesthetic priority? If the answer is no, you are a time-poor generalist. Your prescription is to skip direct isolation entirely. For general fitness seekers with limited time, standard heavy pulling motions will provide enough incidental stimulus to develop forearms organically. Spending extra time on direct isolation at home is an unnecessary luxury. Finally, if you answered yes to that second question, you are the aesthetic optimizer. You have a strong baseline, but you explicitly want larger forearms. For you, the tedious work is required. You need to carve out an extra 10 to 15 minutes specifically for high-rep, localized failure work using whatever bands or light weights you have available. Training in a home environment with limited equipment forces a different set of rules than a commercial gym. You don't have the luxury of perfectly loading every single muscle group. At-home training is an exercise in resource management. Treat your time and your energy as capital. Only spend it isolating small muscles if the physiological returns align exactly with your specific goals.